Okay, started the recording. So we'll now go into the lecture. Okay. So once again, I welcome you to the week 12 of the live sessions for the engineering graphics and design course. So this is the last session for this last live session for this course we will be having. So as you know already, the course instructors Professor Dr. Sunil Kale and Professor Dr. Naresh Datla from IIT Delhi, and myself, I am Vikram Balaji, research scholar from the Department of Mechanical Engineering at IIT Madras. So we will go into this session. So previous session, what we learnt. So we learnt about the assembly module. So how to we saw that there are two methods in assembly module. First is the top down approach. So we create the parts in the assembly module and then assemble there itself. And another thing is a bottom up approach. So where we created the parts previously and then we inserted the parts in the assembly module, and then we made the constraints to get the assembly. So that is one example. Also we saw about the assembly module, the bottom up approach, in the last session. So as you might have seen in the lectures of this week, so this current lecture session we will be seeing with the one example of the animation module. So animation module is actually not a module. In the assembly module, we are going to create the assembly, and then we have to create the animation by giving the certain degrees of freedom. So we will see this example for today. So we have a, you can see in this picture, a double slider crank mechanism. So this is sheet 1. So you can see there sheet 1. So this mechanism is composed of 3 parts. So there is 3 parts, you can see here, part 1, part 2 and part 3. So that part, so 3 parts you can see. One first part is the base, the second part is the this thing link, and third part is the slider, you can see. So we have 3 parts. So out of that the assembly is shown here. So how the parts are assembled together. So part 1, and there is this part 3, 2 parts are there, and then there is a part 2. So this is a base. So these 2 sliders we have, and then we have a link which connects these 2 sliders. So you can see that once we move this slider, or if we rotate this link, so the slider moves, or the same way if the slider moves, the link will start to rotate. So actually you can able to create this animation. We'll do that in this example. So what we have to do is we have to create 3 part models first. So part 1, part 2 and part 3 will create first, and then we have to assemble these parts using the assembly module, and then we have to animate the mechanism such that when the connecting link rotates, both the sliders move in the perpendicular directions within that slot. So how we are going to do, we will see this today. So first we are going to go to the inventor, this thing. First we are going to go to the inventor. Yes. So here we are going to create 3 parts. So we are going to select this first, the part module. So we are going to click the create. Okay, so we are into the assembly, the part module. So first we are going to do the parts. So part 1, then part 2, then part 3. So part 3 we have 2. So we will create the parts one by one. So the diagrams you can see here is part 1, part 2, and one more part 3 will be there in the next page. So we will now create. So this is like a plus sign. So first we can create this part. So let me create the sketch. So we will go to the sketch environment, select this base plane. We make this top perfect. Then we do the, we'll see the rectangle dimensions. So this is 297. So which means if I see here this length and this length also, it is going to be 297. And same way I can, same will be the this one height also, because it is symmetric. So this will also be my 297. First, and what will be this means this is given as 37, which means that this will be 37. Same way this will also be 37. Okay, so now we are going to create this sketch. So 37 I give, then 297, create the sketch. So one more thing, I will create another horizontal. So this is be 297, this is going to be 37. So I have created this plus. So now what I am going to do, I am going to trim the inside edges one by one. So this one I am going to trim. Here also I am trimming. Here this one and this one. So after trimming we see that the constraint is now again gone. So we'll try to reconstrain. So we'll give first the symmetric. So this edge and this edge, and we are going to make it symmetric with respect to z axis. So now this is constraint, and now we will try to give dimension constraint. So 37 means this line to middle. Okay, let us try to give the symmetric. We select this, and we give the x axis. So now I have constrained. So I am going to give the finish. So now I am going to extrude. So I am selecting the profile and I have to give the height. So height is 10 mm, you can see here. So 10 mm, going to extrude, and I got this part. So now what I am going to do, I am going to create another part, another plus within inside, and I am going to make a cut extrude, so that I get this part 1. So you can see it is empty inside. So I am going to make a cut extrude. So for that I am going to do one more sketch. I select this top, and again I give the select, I make the rectangle. So before going into that, we have to see what is the dimensions. So we have to subtract 6 mm. So it will be 6 mm. So this is also 6 mm. So inside will be 25. So which means 37 minus 6 will be 31, and 31 minus 6 will be 25. So inside this will also be 25. So if I am going to make this also 6 mm, and here also 6 mm. So again, if I subtract 12 from 297, I am going to be left with this to this. It's going to be 285. So this is going to be 285. So 285 and 25, that is going to be my rectangle dimension. 25 and 285. The same way I am going to draw from here also 285, 25. So again I got that thing. Now I am going to do the trim again one by one. Okay, so again there is a constraint has been removed, so I am going to reconstrain by doing the symmetry. So I select these two and I do it about the z axis. Now that has been achieved. So again I am going to select this line, and I am going to constrain then about make it symmetric about the x axis. So now it is fully constrained. So I now finish the sketch. So I am going to select the extrude command. I select this profile, but instead I am going to select the cut and I am going to give the up to next. So automatically it selects 10 mm, and now we got this part 1. So I am going to save this in week 12. I am going to save it in the name of base. So that is going to be the part 1. So now I go to home, I select this new, and I am going to create another part which is going to be the part 2. So we will see the part 2 now. So part 2 is simple. So we need to just create this is called as so part 1 was called as base. This part 2 is called the link. So part 2 is called the link. So link is, if you see, the link is going to come inside this slot in the base. So here although the dimension is not given, we can select this to be as our 25 mm. So why it is 25 is, this link is going to see this basically, if you see, this slider is going to sit inside this base, and this link is going to place on this slider. So whatever the maximum dimension of this possibility, so this maximum could be 25. It cannot it need not be more than 25, or it is not necessary, because you can have any mm. So just for the convenience we are saying it is a 25 mm, so that it correctly the matches. Otherwise we can have anything, we can have even higher or lower also, because only the slider is going to sit inside that base. However this will going to be on top only. So we can have 20, we can have 25. So although the dimension is not given here, let us consider it as 25 mm, and this length is 120 mm. So I am going to create a 120 by 25 sketch on the base plane. Select the rectangle, the center command, select the center, 120 by 25. So finish the sketch. I am going to extrude. What was the so thickness is 4 mm. It is given here 4. So now I created this part. So what is there means I have to create 2 holes. So these holes are 8 diameter. Okay, I am going to create a hole. I have selected here from this edge to that edge. It is going to be, so it is going to be, let us assume symmetric. It is going to be 12 mm, because 120 already, if you subtract 12 and then 96, the remaining will be 12. So this will also be 12 mm. 12 mm. The hole is diameter is 8 mm. Yes, and this is going to be center to center, center to edge, going to be 12.5. 12.5, and now I'm going to select 2 to this surface, select OK. If I see the top view, I get that hole. So let me come to home view. I'm going to copy this hole, or I can make a pattern feature, select this hole. So direction, I give this direction, I flip the direction, let us say spacing is 96. So we get this hole here, only one direction, so we got that hole also. So this part is done. So I am going to save this file. Let me save as this is going to be link. Okay, fine. So base and link we have created. Now we are going to create a slider. So new, again I'm going to create a new part for slider. So let us go to back to this. So you see here, part 1 is done, part 2 is also done. So next we have to go to part 3. So part 3 is the slider. Okay, so we see here, this is 40 to 25 dimensions, 42 length, 25 in width. So first we are going to create that sketch, select the base plane, make it straight. So my dimension was 42 by 25. Okay, finish the sketch. Now I'm going to extrude it. So for how much? It's going to extrude for 2 mm. For 2 mm. So I got the. So next I have to make a small pin. So that pin, so this diameter here is not given, but we can see the diameter from this link. So whatever is going to be the diameter of the hole in this link, the same will be the diameter of this also, because this pin is going to fit inside the hole in the link. So this also you can say it is a diameter of 8. Since we this, so it is going to be the same diameter. Okay, so dia 8. Let me make a small pin on top of this. So select this sketch, this plane. In the center I'm going to make a circle of diameter 8. So that also finish. How much I'm going to extrude means I'm going to extrude it for a distance of 4 mm. So let us click. So here 4 mm. I created the extrusion. So the pin is ready. So I will save this part also. So base link, and this is a slider. Okay, so we have created the 3 parts. So let us review these parts one by one. So part 1 we created, we called it as the base. Part 2 we created, we called as link. Part 3 also we created. So this will be called as slider. And we let us underline this green color. So it means that we finished this part. So let us now go to the assembly. So as we see in here, so first I am going to insert the part 1, and then the part 3 we can insert, and then we can insert the part 2. Okay, so how we are going to insert and what constraints you are going to create, we will just look in a short while. So I have saved all. So now I am going to the new, I am going to go to the assembly module. So in assembly you have these many options. So we are going to go for the standard option. so millimeter. So I click the create. Okay, so now we have gone into the assembly module. So now we have to place the parts one by one. So first let us place the click the place button. So let us go to this equal. So first we can place the base. So I click the home view. So here you can place it anywhere. So let me place at this point. So we have placed it. So we click the escape. So which means that we have placed one part. So if you select this drop down, you have many options there. If you go to degree of freedom analysis, you see that it has all the translation and rotation degrees of freedom. So what I am going to do, I am going to make this fixed. So for that I am going to select this. Now it becomes a blue color. Going to right click that, and it is I am going to enable the grounded. So which means that I cannot move this. So if you click on this thing, so for example if I remove the grounded, so now only the mouse is there. So if I right click and click the grounded, that means if you click here, you can see that some symbol along with the mouse symbol is also there. So that is a pinned symbol, which means that this part is now fixed, which means the degrees of freedom are all arrested. So you can see if you go to degree of freedom analysis, now translation 0, rotation is also 0. So this grounding we saw already in last example, just I am reiterating. So part 1 we have inserted. So let us now to try to insert the other part. Other two parts are there. So this part I have inserted. So next we will try to insert the part 3. So one by one we'll do that. So we click the place. Now part 3 is slider. So click the slider, click open. We will now insert here. So what I am going to do, this slider I want to insert in this slot. So first what I am going to do, I am going to click the constraint. Okay, so what constraint I am going to do, I can use the flush constraint. So here I am going to, or I can use mate constraint. So flush first I will make the flush constraint. So I am going to this top surface, and this top surface of the base I am going to match it. So I click the constraint option. I am going to go for the flush option. So I click this top surface of this slider, and again this top surface of this base. So offset is 0. I click apply. So if you see the front view, we see that this top and top are now coinciding, but still it is not constrained. It can move anywhere in the x and y. So now I am going to do a new constraint. I am going to mate two surfaces. So first surface is this left side surface of the slider. Another is I am going to mate this surface. So now we see that this slider can move inside. It can move this way, anywhere outside the in and inside also. But further we are not going to constrain this, because this is a slider and it is going to slide. It has if you see here degree of freedom, it has one translation. So it can translate along the x-axis. So we are going to keep it that way. Now yes, so now we are going to place the other slider. So I place here one. I click escape. So I am going to create constraints. So first constraint is I am going to mate the top surfaces. Sorry, flush. I can create the flush command. This is my first surface. This is my second surface. So both are now flushed, and same thing I am going to create a mate surface. I am going to click this surface, and I am going to click the inside of this surface. So which means that it has now this thing. So I have two things. Okay, so I can slide this. So let me select these two things, and I'm going to give a new color just to make it distinct. So let us say that we are going to give some light red. Okay, so now we have to insert another this thing, this what you call part. So just before that, we click the degree of freedom analysis. The slider 1 as a one translation, slider 2 as a another translation. Okay, so now click this place command. I'm going to click the link, going to give the open, paste it. So first I'm going to mate two surfaces. So which two surfaces I'm going to mate means I'm going to mate this bottom of this link, and I'm going to mate the top of the slider. So any slider, if you mate it with this, automatically it will be mated along with the surface also. So let us do that. Constraint, I click the mate. So first surface, bottom surface of the link, second surface, top surface of this slider. Okay, that has been applied. So still we have to do some more. So I'm going to mate one more thing. I'm going to select this whole axis, and then I'm going to mate it with this. So now we see that this thing as a, so one more we need to do. So before that, we just click and see. Okay, so one more, I'm going to constrain, apply the mate, this one, this one. So if you see degree of freedom analysis, now it is updated. So you can see that slider, each slider has only one translation, but link has 3 degrees of freedom. It can translate along x-axis and y-axis, and it can rotate also. So it is now in a proper mechanism point of view. So now what I am going to do is I am going to, so we have created the assembly. So let me take this thing. Yes, so part models we have created, and we have also assembled the parts. So now I am going to create the required animation. Animate the mechanism such that when the connecting link rotates, both the sliders move in the perpendicular direction within the slot of the base. So they have to move in the perpendicular direction. Yes, so the connecting link should rotate. So how I going to create the animation, we will see now. So first of all, we do additionally one constraint. So I'm going to give the angle constraint, and I'm going to select. So how I'm going to give means I'm going to select this what you can say, this surface I can select, this surface, and or not that surface, let me say maybe this surface I can select. So constraint angle, so this option, direct option, this surface, and we have to select this plane. So what plane we can select means not this plane, not this plane, yes, xy plane we can select. So this is 0. So if I give suppose 90, is somewhat this angle. If I give 90, this angle. If I give 135, it is going to this angle. So if I give 180, it is going here. So if I give 200, it is going this way. Let me give some 250, it is going this way. Let me give about 270, it is going this way. Let me give some 300, 320, 345. Let me, if it's going like this, again 360, it came back to this position. So if I give 0, it is in the same position. So let me give the 0. Okay, so this I select. I am going to give maybe a new color for identification. So we created. So if you see the degree of freedom analysis, now all are constrained. Or let me say I am going to maybe see the relationships. You can see that there are many constraints here. You can see one flush mate, mate, again mate, again mate, again then angle. So here I can go, I can give the edit. Let me say that I select some 45 degree. Simply we can keep 45. Now first we will generate assembly drawings, and later we will again do the animation. So we will save this assembly. Let me say so we have this name, double slider crank. Mechanism, or I will say just assembly. So we save it. So now I go to home. Give the new. We'll create one drawing in ANSI MM. Okay. So now we are going to create a base. First base view. So here we are going to select it. Week 12 double slider crank assembly. This is one thing. Let us say this is front view. Let us try to increase the scale. Okay, we will have 1:1 itself. So you can see this is one part, this is one part, another part. So if I try to create the projected to this thing, I can create a top view. So I can select here and place the top view. Can move this. Okay, I have created two. I will try to delete one. Yes. You can see here. The top view you can see. All the three parts are visible. So now I can create a side view. Maybe I can create as a projected. So I will create one here, or I can create a section view also. I select this view, create this line, vertical line. So here we have the section view. So I can try to give the parts also. Balloon, this is one. Select here. So this is 3. So this one would be 2, I think. If I select this, this is 2. So 1, 2, 3 are given. We'll also insert the parts list. We'll keep it in the top. So we have the item and quantity number and base, one base, 2 slider and 1 link. So we'll now save this assembly drawing. Okay, we have now saved it. So let us now go back to the assembly only, and we'll now to create a animation. So we here some angle is there. So I'll go edit. First I'll make it as 0 so that let it be vertical. Now I'm going to right click this and give the drive. So if I give the drive, so it starts at 0 and ends at 10. So let me make this end at 360, and I go for the more options. So I give the start and start, maybe one this thing. Total number of amount of increment I give by 1 degree, and this is AVI rate, this is 10, let it be. Okay, so if you see here, if I now click this thing, so it starts. So from 0, 90, 180, this is 270 and 360. So now if I do this, it goes to back 180, 270, finally 360. Yes. So let me give 2 things, 2 cycles I can say. Now we will see what happens. So here you can see the position is keeping changing, angle. So now it has come the reverse. Yes. Okay. So I can try to record it. So constraint I can give. So maybe I will record it here. Double slider mechanism. Let me put that. I am saving as a WMV file. So I'll give OK. So again I'll try to do this thing. So it is now slowly going. At increments of 1 degree it is now rotating. it's very slow. You can see this rotation. So now from 0 to 360, now it is going to the reverse cycle. So again it will go from 360 to back to 0 in the reverse direction. So it has now come back. So it was this thing. So it was very slow. So let us try to give increments of 10 and see how that happens. It's much faster. Okay, so we'll try to record this also. When the stop mechanism, will give bracket 10-degree increment. Let us save it. So we'll see. So this is the video, I think. We'll click and see whether it is saved. We open through VLC. Okay. Okay, I think some problem is saving. So anyway, now the animation we have just seen. So we can just save plus the record. So this again I am playing the animation now. Yes. Okay. Maybe there's a problem in the recording in my computer, so you can try to record it, or you can just try to play it here, so that anyway we have achieved what we have tried. So we have created the animation also. Okay, so with this example we are able to create one animation. We first will just finally give the summary. So we saw that we are going to do a double slider crank mechanism. So we had 3 parts. We first created the 3 parts in the part module, and then we created the assembly by bottom up approach by assembling these first creating these parts and then assembling these parts together into this assembly. After this we finally created the animation. So this is part 1, which is a base, part 2 is the link, and part 3 is this slider. Okay, so with this we come to the end of this session. So any doubts till now? or shall we? Is there any doubts? If any part you are feeling doubt, I can try to demonstrate once again. So, are there any doubts in the example which we saw? So, we just saw one example of how to create animation of a mechanism. Any doubts are there? It's clear. Okay, thank you. Okay. Okay. So, if there are any no more doubts, I think we can close the session. So, as I said, this is the last session of this 12-week live session program. So, please, if you like the whatever you have the feedback or comments, you can give it in the survey. So, I think everybody would have received a mail about the survey of these live sessions. So, please feel to provide your comments on whether I need any improvement or what could be, what was, is there anything this thing. So, computer based exam. So, any exam based doubt, so I am not aware. So, please you can contact the professor regarding this, because I am not aware of the exam related queries. So, I just those are sample assignment questions I am we will solve. If possible, I will try to email the professor and try to give the I'll try to ask him about the exam pattern. So, if I will maybe I will later let you know also. Okay. So, any other doubts? So, in this particularly about this assignment or any other assignment. So, if there are no doubts, I think we can close the session. Okay. Okay, so I will stop the recording. So, thank you guys. Have a happy weekend. So, all the best for your exams also. Okay, so I will now stop the recording.